Alright, now we're going to look at what's referred to as Theorem 1.9, which contains just two trig limits that basically you just need to memorize. Of course, like in the textbook, they go through the steps, to prove to you that this one's equal to 1 and that this one's equal to 0. But like I said, you knowing that it's equal to 1 and 0 is not something you have to know. You just need to memorize. So if you have the limit as x approaches 0 of sine x over x, that will always be equal to 1. One thing that I want to point out about this one is whatever you have here, which is considered the argument of your trig function. So whatever expression you have here in the argument, you have to have exactly the same here. So it's not always just an x. They can have something else just as long as this is the same. And then the other one, you have the limit again as x approaches 0 of 1 minus sine x over x. And that one would be equal to 0. So you're going to use those two as we go through these examples. Alright, so the first one that we're going to look at, again, we're just determining the limit here. So we have the limit as x approaches 0. This one actually just requires a little bit of rewriting. Now remember to continue writing your limit notation here until you actually take your limit. So I'd have the limit as x approaches 0. Now I can rewrite this as just 3 times 1 minus cosine x over x. Okay, so like all of this is this. I'm just pulling the times 3 and putting it out front here. Now, you are allowed, and we don't have to take the steps to write it, I'll just tell you what you're doing. You are allowed to take the limit of these two parts individually and then just multiply those two results. Alright, so first of all, I have the limit as x approaches 0 of 3. Now, I had given you it was listed as a theorem earlier. Anytime that you have the limit of a constant, then the limit is just that constant. So the limit of 3 would just be 3 times. And then you have the limit as x approaches 0 of this portion. And this is actually the second one on the list that I had just given you, in which the limit as x approaches 0 of 1 minus cosine x over x would be just 0. So 3 times 0 gives you 0. Okay, next. I have the limit as theta approaches 0 of cosine theta times tangent theta divided by theta. Alright, on this one what you've got to do is actually just use some of your identities to help you out. Alright, so first of all, what you're going to want to do is replace tangent with the ratio identity, which is sine over cosine. And then doing a little bit of simplifying here in your numerator, what will happen is your cosines will cancel out. So that would just leave you with sine theta over theta. And of course, this is exactly that first trig limit that was on that list. So therefore, that's just equal to 1. Okay, number 3. Alright, first of all, on this one, again, just doing a little bit of rewriting. I'm going to pull out a fraction here of 1 over x. And of course that would then be multiplied times the tangent squared. It's just pulling your fraction out front like you've done before. Then, using the same identity that I did a while ago, I'm going to rewrite this one. So that would give me, now since this is squared, then I would have to do sine squared over cosine squared. Again, that's just using that ratio identity. All right, next, what you're going to want to do is actually, again, just basically rewriting what you have here. Of course, this being sine squared, that means you've got two of those. So I'm going to take one of those and pull it over here. So that would give me sine x divided by x times sine x over cosine squared x. Okay. Now, of course, this part is the first one that was on in that list of that theorem. Okay. Now, I mentioned a while ago that when you've got these two things multiplied, you just work with those, just do the limit of those individually. So, the limit of this portion based on that theorem is just 1. Now, on this one, let's do our direct substitution. So, I've got the limit as x approaches 0, so I'm going to directly substitute in 0. Now, sine of 0 is 0. Cosine of 0 is 1. Of course, that's just the same thing as 0, so 1 times 0 just gives us 0. Okay, so you had to use your identity there and a little bit of, manipulating your problems. All right, next one. Now this one, when you look at it, it looks almost exactly like what you need. And I mentioned this earlier. What you've got to remember is what you have here has got to be the same as what you have here in order to use that property that we've been using. Now, you cannot change this argument in any way. Whatever this is, when the problem is given to you, this has got to stay. So if this is just an x, then really what I have to have here is going to be just an x. But since the 7's being multiplied times the x, you can just pull it out front. So you're going to rewrite this. And you just have 1/7. Of course, it being on the bottom, you got to understood 1 on the top. So now you're going to have 1/7 times sine x divided by x. Now this looks exactly like that property. So the limit, remember you do the limit of these two things individually, so the limit of this constant would be just that constant. And that property states that the limit of this would be equal to 1, so then you just do the 1/7 times the 1. Therefore, your answer is 1/7. Okay, this last one is similar to the one that I just finished working. Just basically need to manipulate it a little bit with the numbers. Okay, now remember, whatever this is, that's exactly what you've got to have down here. You cannot change this 5x. So if you've got a 5x here, then you've got to have a 5x here. So first of all, I'm going to get rid of the 3. I need it to be a 5 and not a 3. So I'm going to pull that out as 1/3. Okay, now of course that doesn't fix my problem because I still don't have a 5 here. But you can put numbers in as long as you counteract it. Okay, so like what I mean is if you add something, you've got to turn around and subtract it. If you multiply by something, you've got to turn around and divide it because that just counteracts what you're doing. You're making it look different, but value-wise, it's staying the same. So what you would need to do is if I'm going to put a times 5 down here on the bottom, of course, I know I'm multiplying it times the x, but in aspect of this whole fraction, actually what I've done is divided by 5. So if I've got to divide this fraction by 5 in order to make these two things equal, then I've got to turn around and counteract it and multiply by 5. Because, see, you don't want to cancel these out, but I'm just saying in writing it this way, those 5's cancel out, which would just take you back to what you had in the step before. So your value-wise, it's the same, but you're making it look different. Okay, so now let's just put these two together. That would just be the same thing as 5/3. So the limit of 5/3 would just be 5/3. And of course now this is that property and the limit of this would just be 1. Therefore, your answer is 5/3.